Good afternoon.
Good afternoon, sir.
Is the screen visible? Is screen visible?
Yes, sir.
Yes, sir.
Okay, done. Okay.
Yes,
fine.
sir.
Yes. So welcome to the second topic of mission dependent loader features. In the previous class, we discussed about program relocation. Now let us look at the program linking. So if you remember or recall, there are four functions of a loader. One is the memory allocation, program linking, program relocation, and program loading into the memory. So program relocation we have seen, which was in similar lines of assembly level what you have seen, but only thing is we discussed about how the relocation can be effectively handled by using the relocation bit or bit mask. That was only a facility that was added at the time of creating an object program such that your loader need not waste a lot of time in loading a big program that is involving a larger set of direct addresses. A better solution for that is to accommodate a 3-bit or maybe a bit mask, which we call it as a relocation bit or a bit mask, which was a convenient way of looking at the relocation for a bigger programs which that involve majorly direct addresses. So that's fine. So that's how the relocation was accomplished. Now the linking. So if you recall from the assembler, we have taken control sections. If you look at control sections, each control section is a independent entity, meaning that control sections are one of the important assembler features that enable the program to exist separately, to assemble separately, to link separately, to load separately. So that is a concept with which we have looked at the control section. Even if you look at the example what we have taken control section 1, control section 2, control section 3. All these three exist on their own separately with separate start, end, separate object program. All those stuff are happening. Why that was there? Because the control section, the existence itself is like that. That means they exist independently, they exist separately. They will be linked together only when it is required at the time of the execution of the program. For example, let us consider three programs: program A, program B, and program C. These programs have been written such that each program, that is program A, is independent from program B, and program B is independent from remaining two. Like that, program C is also independent from program A and B. If that is the case, each of these three can be separately assembled, can be separately linked, or can be separately loaded into memory. That is the idea with which we have seen the control section. The same concept what we are going to consider now, but what we see here is, since linking being an important functionality of a loader, how linking is going to be carried out by the loader is what we are going to see. In simple terms, if I say program A, program B, program C are three independent sub programs. Each will be have, when I say independent, each will have its own separate or unique object program, and also they will have their own starting address and other stuff. Okay, so if that is the case, when I submit these three programs together for execution point of view, what will happen? Program A is away from program B, and program B is away from program C, and vice versa. So all these three programs are existing elsewhere. Assume program A is at the location 5000, program B is at the location 10,000, program C is at the 15,000. Just we are just considering for our understanding point of. That means each of these are existing at different places in the secondary memory. Now what loader is going to do? The loader is going to bring all these three together. Is it bringing all these three together? We have given in the execution mode that execution command that program A should take program B should involve program C, and program C should involve program A. That means there is some interconnection between or among these modules, and hence we want these three things to be loaded, linked together first, then loaded into the memory. That is a requirement. Or let us say only program A and B need to be linked together, or only B and C, or only A and C, or all the three. Depending upon the requirement, we can inform the loader that I want to have more than one program to be grouped together, so that there is some dependency, I can say interdependency between or among these modules or subprograms, such that when they submit together, we will be having a proper execution of the program. If that is the need, we will be normally sending or informing the programmer as operating system that link these 3 or 4 or 5, whatever may be the number, sub-programs together, so that they can be loaded for execution. That is a requirement. If that is a requirement, we call that there is a process called linking happening between or among these three. Meaning that program A, program B, program C, just till now they are independent. They are existing at their own places. One at 5,000, other one at 10,000, the remaining is the 15,000. Now I want to group them together. Submit for the execution. When that is the case, program A, program B, program C, there should be some connector, some communication. So program A should be engaging with program B, and program B with C, and like manner, we need to have the engagement between these three, or there should be a communication between these three. Similar to your objects in a C++ or Java. When you have created objects independently, we can create objects, classes, objects of that particular class, start using them. But you want to have one object of a class communicating with another object, there should be some mechanism. That mechanism may be through your friend function and stuff like that. So there should be some connecting mechanism. Similarly here, when we submit the program for the execution involving more than one module or one subprogram, we also need to connect that. So that connection is what we call it as a linking process. So linking is a mechanism, linking is a process rather, in which more than one module or more than one subprogram, which are till then are independent from each other, will be linked together or will be combined together, so that when you project to the system, you are going to project now as if it is a single program or a single entity. Till that point of time, they're all existing separately. Now we are projecting to the system that you are a single entity. So a similar analogy we can take in the current political system. So there are 100 parties existing, let us say. Each party is independent. But when it comes to the election time, when it comes to the election campaigning, what will happen? There is a lot of grouping and regrouping and ungrouping among the political parties. They project as if we are from NDA, we are from UPA, we are from, say, Mahagathbandhan, whatever the names they want. But at the time of election, they are going to project together as if they are all in the same plane. It's a similar concept here. So linking is nothing but, till then, all these object programs are separate from each other. They're existing separately, no communication at all whatsoever. But we have a requirement wherein one program is having some data in other program, or one program is depending on the other program for whatever may be the purpose. We need to connect them. If that is the case, the linking process comes into existence. So what is the input for linking now? For linking process, we have a multiple subprograms or modules which are independent existing, which are independently assembled. So now our task is to group them together. While grouping them together, I should be providing the link from one program to another program, from the other program to another program. Like that, at the end of the linking, what will happen? There will be one communication channel among all the programs. For example, if I have a program A, program B, program C, before linking, program A cannot communicate with program B or program C, and vice versa. After linking, what will happen? Either of them, A can go to B, B can communicate to C, C can communicate to A. Anyway, that means A, B, C can communicate together as if they are in a one particular family, as if they are in one particular group. So that is what the outcome of a linker. So initially, when linking process was about to happen, the about to be linked programs are all independent. But after linking, what will happen? Those independent programs will be projected as if they're a single module or single entity to the system. So after that, what will happen? It will be loaded into the system, that is your main memory, as if it is a single block of data or a program. That is the concept of a linking. How it is being done, let us see. We'll also take some 3 independent modules in line with the control section and understand how this is being processed. Is it clear now till that, the concept of linking? Any doubts? No doubt. Let us take the example. We have 3 independent programs here. So let me show one by one. If you could look at this, this is one program called as a program A. This is one entity. This one entity is having one subprogram by name program A. Similarly, I have another program by name program B, which is existing separately. This is program B. I have another program, program C, which is having separate existence, which is pointed here in the program B, or program C. So 3 programs. One is program A, program B, program C. Now for program A, we have a separate object code. This is object code for program A. Similarly, for program B, we have a separate object code. Similarly, for program C, separate object code. So this is before linking. So before, this is similar to your control sections what you have seen. So that's what, if you observe here, whatever the control section program we have taken, we have reused them, but only thing is we have given separate names: program A, program B, program C. When I'm in program A, this is the first control section. When I'm in program B, the second control section, program C, the third control section, I need to be very careful which are my external definitions and which are my external references. We know that from control section we have seen external definitions are those which are defined and used in the current control section only. They are also defined, they are also used here only. For example, list A and NDA, have they been defined? Yes, list A is defined, NDA is defined. So they are defined here only. Have they used them? Yes, I have used them. List A I have used, NDA also I have used. So I have defined some variables, I have defined some labels, and also used them in the same control section. I call them as a external definitions. Next, external references are those which are used in the current control section but defined in other control sections. For example, list B and B, list C and C. They are not available anywhere here, but I have used them. Where are they have used? I have used end C, I have used list C, I have used list B, I have used end B somewhere. End B here. So like that, I have used them here, but I have not defined here. So they become the entity of a external references. Similarly, we have external definitions and external references in program B and as well in the program C. So this is nothing but now a control section for us. Okay, that is the idea. We have used control section C sect earlier. Now we have replaced that word by program A, program B, program C, just to understand how it is done. So what I would observe here is just to give us a idea how linking is taking place. The instructions what we have used, please observe here. The instructions and operands what we have used here are same in all the programs. LDA, LDT, LDX, LDA, LDT, LDX, list A, list B plus 4, NDA, list A, list A, list B plus 4, NDA, list A. Like that in every system, I mean every subprogram, we have maintained just only for our understanding, so that linking gives a common number or common address for all of us. Okay, so the instructions what you see in every subprogram here are pretty same, or rather we have maintained such that they will not be creating any confusion when you want to calculate. And also to identify them, we have given some labels: REF1, REF2, REF3, like that. We have given some labels. They are also retained as it is in across the three programs, just to make us comfortable in understanding this concept of a linking, that is a program linking. So this is what we have to observe here. So we have taken three subprograms which are independent in existence, which have separate object program, but which are having a common instructions and operands, such that, why so? Because we can relate or we can understand the linking is happening across the subprograms in the same fashion. So how do you say how is the linking is happening? Now let us take an example of the first program. In the first program, we know that only list A, list B are available. So list A, NDA are available. All other things are not available. For example, we have used list B here. In line number 23, list B is used. I don't know the value of list B. In line number 54, we have used list C. I don't know what is list C. In line number 57, we have used end C and list C. We don't know what it is. Okay. Similarly, in line number 5A, 5D, something, we have used some values which are not part of my current control section. But when I link these three together, where is a list B for me? List B is available in program B. So where is program B? Here. See, program B, list B is available. Similarly, where is list C? List C is in my program C. So I can add. That means when I link these three together, there is interdependency. Now when I link these three together, after linking is over, everything is going to be a single entity. At that point of time, all this missing data will be available. So when I link program A with program B, anything related to program B, that is end B and list C, data is available with me. Similarly, when I link A with C, anything related to program C, that is end C and list C, are also available. Then at the end of the linking is over, I will not have any undefined symbol here. Am I right? Because by then you would have resolved all those problems. So linking is going to enable any missing links to be recovered, or any missing links to be adjusted, or any missing links to be get clarified. That is an idea behind the linking process. Linking process should always, it is like a linking more than two bogies in a railway rail chain. If that is the case, we are going to link each other such that there will be some connectivity between those two compartments, so that no harm will happen to them. So that is the concept, same concept of linking here. So multiple independent blocks of program are brought together to just say that they are going to create a single entity of the program, such that program execution will be easier. So by the process of linking, what are we going to do? Any unresolved addresses or any unresolved things between or among the programs that are under discussion, if at all they are existing, they will be removed. And at the end of the linking process, they all will be projected as if everything is same, everything is available. There is no missing details at that point of time. If that is the case, we say that the linking process is completely successful. So that is the idea. Now, how it is being done? So we have taken a program, rather set of programs, three programs, program A, program B, program C, such that each program is having the same list of instructions and data, so that we can identify or resolve easily how the addresses are going to be linked together. So for that purpose, let us look at the object program. If you look at the object program here, there's so many modification records. But if you look at that, when I'm in program A, I require modification records for those which are not having the proper values. What are they? They will be the addresses that depend on the actually your program B and program C. That's what we see everywhere here. Okay. Now, similarly, you have a set of programs having modification records for program B. Similarly, modification records for program C. This gives us a flare idea that, oh, there are so many modification records that need to be engaged. Why the data is not fulfilled now? We know that in control section, we will not be knowing the data of a another control section well in advance. The only solution is to link them together. When I link them together, I will be able to know the data. Okay, so this is the idea behind the beginning of your linking process. But this is not end, because we have not accomplished anything. We have just brought, we are assuming that these three programs will be brought together. When they are brought together, there are so many address issues will be resolved. How they are going to be resolved is the question. Once address issue is resolved, all these modification records will be handled properly. There will not be no list A, NDA and all, because the values would have been known by then, and we'll be able to figure out them and complete the loading of the program. So let us see what is the solution for this. And these three programs now, just a representation in memory now. So program A is loaded here, program B is loaded here, program C is loaded here. So let me know when this is going to be feasible. Is it possible before linking or after linking? We know that program A is at 5,000, program B at 10,000, program C at 15,000. Independently existing, but I'm going to bring them together. When I bring them together, they will be existing in a continuous memory locations. Otherwise, it is not easy to link the process properly. So if that is the case, system will make sure that the entire program, that is the program A, program B, program C put together, is going to be residing at one particular place. That's what you see in the memory. So program A is starting somewhere at 4,000, let us say. As per the main memory is concerned, it ends at somewhere at the 4061, 62, 63. After that, immediately program B resumes. Program B has started. It will go up to this particular value. Once this is done, program C will resume and program C will be started loading here. Once that is over, program C ends here. So program A, program B, program C before linking are scattered, but after linking they are together. That's why we are going to demonstrate through this memory diagram. So this diagram is after linking. After linking. So after linking, what we'll do? We'll load the program into the system. That's what happened. So once linking is over, the entire set of programs or modules as a programs will be projected as if they are in the single entity. Okay. Now, so this is the table what we get. So initially, our control section program A was loaded at the location 4,000. It went up to 4,063. You have just now seen in the memory. So 4,000 to 4,060, 61, 62. Next becomes the 63. The difference is going to be 63 units. I mean 63 bytes. So from 4,000 up to 63, that is a 4,063. So this 4,063 will become the address for program B, because they need to be loaded at the continuous memory locations. Once program A is over, then program B has to resume. So at what point of time program has to be resumed in the memory? This is the calculation. What is the calculation? The starting address of program A plus length of program A. Starting address is 4,000. Length of program is 63. So 4,000 plus 63, again hexadecimal here, 4,063. So 4,063 becomes the starting address for program B. Similarly, the length of program B is 007F. This 007F is added to the 4063 and it becomes the starting address of program C, that is 40E2. Like that, we are going to create the program A, program B, program C starting address. Once I know the starting address, then I can calculate my list A, list B, end B, list C, and end C values. Because initially we have assumed that we are all starting at the location 00000. But now we have come to the conclusion that the addresses are identified now. Once first program is loaded at 4,000, its length plus whatever we have, the data will become the starting address of the next program. Similarly, the length of this program B plus the starting address of program B will give us the starting address of program C. Suppose we had another program. That is program D. What would have been its address now? 40E2 plus 4051. Whatever that comes is could have been the address for program D. Since we don't have, no problem. But if at all it was there, that's how it should be calculated. So we are going to group all those independently existing so far entities or subprograms now together. When you are projecting together, there should be some connectivity. This is the connectivity. What is the connectivity? Whatever the address we have left for the program A will be the place where the second program will continue. Like that, entire module which we are using for this particular linking process will be considered as a one big program or one big entity. That's what we have to understand. Now assume instead of 4,000, the program has been shifted to 7,000. What will happen now? The 63 7F 51 is not going to change. What will happen? What will change only? 7,000 will change. 7,000 plus 63 will be 7,063. Similarly, 4040 would have become 7040. 4054 would have become 7054. So there is no change at all. It's only a relative positional change would have happened, because that's how the linking process is going to be done. So we are not going to have any harm for the program. Program is intact. Only thing is where it is going to be loaded after linking is what we are going to consider, is what we are going to look at this point of time. So what we have seen so far now, we have a program linking process. Program linking process is nothing but linking more than one program or maybe sub-program or a module. Why we have to link? Because there is some interlinking or interdependency between one program to the other program, or maybe more than two programs. If that is the case, to complete the execution, we require the support of the another subprogram or the module. So unless we club them together, unless we link them together in technical words, we will not be able to project them for the execution. So we have to connect them through the process of a linking. How is that accomplished is what we are going to see. So while accomplishing that, so program A will be started at the location that is available in the memory. So from that location, whatever the length of the program A is there, that program A will be completed. After that, immediately program B will be continued. So hitherto, where was the program B? It was somewhere. There was no communication at all. Now, since we want to link them together, we'll bring program B and attach that to the program A in the same memory location continuously. After program B is over, now since we want program C also, we will add the program C. If we want program D, if at all it was existing, we'll add. So like that, how many we can add? There is no limitation at all. Depending upon the capability of the loader to link, we can have 5-10 modules easily to be added together or linked together in this fashion. That is the idea. So now we have the input, we have identified the memory locations. Now how this is going to be accomplished is what we are going to see now. So for that purpose, let us take one example. What is the example? One instruction it has been taken, that is reference 4. So what is reference 4 now? Because we said that every program is same. Why? Because we want to conclude that the result of the one instruction which we are going to get in a program A will be same in the program B and program C. To prove that, we need to have a common instruction. So for that purpose, it is taken that, let me take another pen color. I'll take yellow if it is visible. Yes. Okay, we'll take another. I'll take green. Now, reference 4 is what we are going to take. So, reference 4 is having this instruction. In every program, we will take reference 4 here. Similarly, reference 4 here is here. So, this is the reference 4. If I take this, I should get the same result whenever I calculate. Here reference 4 is this. So 3 programs we have identified the reference. You could have taken anything. We have taken reference 4 because it is discussed here, or we can take anything for that matter. Okay. Let us take reference 4. When I take reference 4 in first program 0054, before linking, what could have happened? End A minus list A plus list C. Where is the end A? NDA is in the same program. Where is list A? List A is also in the same program. Where is list C? List C is not in the same program. So we need to handle list C separately. So for address 0054, you would have written a separate modification record. Let us see. Yes, there is a separate modification record. Why? Because list C is not known to me. In program A, we have written a modification record. Okay, now fine. So this is what. So NDA minus list A. What is NDA? 00. Sorry, NDA is, there is NDA here. There we are in ends. Okay, NDA is 0054. List A is 0040. So NDA minus list A. So 0054 minus 0040. The difference is 14. So 14 is added here. Why it is 14? Because this is NDA minus list A. But where is list C? I don't know list C. So what is the solution for that? At 54, I want to add list C. So now I don't know the value of list C. When I get list C, I need to add. Now what is the list C value? Just now we have seen now. Just now we have calculated list C. What is list C? List C is 4112. List C is 4112. So now I will add 4112 to this. What will happen here? NDA minus list A is 14 plus 4112. So 14 plus, sorry, here. 14 plus 4112, it is 4126. So 4126 is the value at which I have to find my reference for. Let me see whether the diagram is going to give me that. So 4126 is the value where I will find my reference for. So how it is calculated is what we have mentioned in the diagrammatically. What you have seen now, we went to the reference for, we observed 0014 is there, and this 0014 is not enough because list C is missing. For that purpose, we have written a list C as a modification record. We have seen that in the object program of a program A. But where is list C? List C is not in with me, but list C is available with the program C. What is the value of list C? List C is value is already given to us, which is a 4112. We have just calculated like this. We know that how to calculate. So 4112 is calculated. Now I will add 4112 to this 14. That will give me 4126. Why this is possible now? Because program A and program C are clubbed together. Since it was not earlier clubbed, because they are independent to each other, we were not able to get to know the value of list C. Now, through the concept of linking, we have grouped them together, we have clubbed them together, we have linked them together. Thereby, I can resolve any value for that 4126. Now, we should be getting same value across. Let us see how it is possible, because we have taken the same program. Now I will not come to program A, I will go to program B. Any doubts so far? You have done program A now. Before I take program B, program C, any doubts? Meanwhile, let me have attendance. Asta? Abhinav? Ambarish?
Sir, Aishwarya
Yes, sir.
present, sir.
No, I will call only doubt people, not all.
Okay, sir.
Arbaz? Arjun?
Present, sir.
Ashok? Bhargavi?
Present, sir.
Chatterjee? Deepika LG?
Present, sir.
Deepika MB?
Present, sir.
Guriya Kumari?
Present, sir.
Sir, Murali Krishna.
Junjar Singh?
Present, sir.
Kavya?
Present, sir.
Kishore?
Present, sir.
Nilanjan? Priyanka?
Present, sir.
Akash, Ravishankar,
Yes, sir.
Rizwan,
Present, sir.
Shruti, okay. Any doubts? Fine. So now,
Sir Murli Krishna, sir.
ನಾನು ಹೇಳಿದ್ನಲ್ಲಪ್ಪ ಡೌಟ್ ಇದ್ರೆ ಮಾತ್ರ ಕರಿತೀನಿ ಅಂತ.
Yes, sir.
So now let us see program B now. How the same reference 4. So if even in program B, if you look at reference 4, the definition is same. NDA minus list A plus list C. So in program B, all three are unknown. NDA is also not known. List A is also not known. List C also not known. You observe that object code, all zeros, because we don't know what is the value of NDA, list A, list C. Can anybody tell me what type of expression it is? NDA minus list A plus list C in program B. Is it absolute or relative?
Relative.
Relative. Why?
They're all not present in the same program. Variables which are given.
So if they are present, it is absolute. Huh?
No, sir. That
Okay.
address also.
Fine, no problem. You come to program A. Program A also same expression, no? NDA minus list A plus list C. So what type of expression it is now? Is it absolute or relative in program A?
It is also relative, sir. But two variables
also
are
relative.
present
Okay, fine.
in independent while we seeing. Sir.
Okay, fine. Okay, that is one way of identifying. But other way of looking at absolute relative is when you have a odd pair of variables. Odd pair means if you have pair of variables, that is 2. If you have 3, there are also terms, but if I have 3 terms, that is not a pair, no? I can make only pair, one pair, other one is odd man out. So that also becomes an example of a relative terms. In both these cases, it is matching here. So when you have, or when you don't have a proper pair of verb, pair of symbols, then also it is going to be relative. So in both the cases, it is relative. Good. Now, in program B, NDA, list A, list C are unknown to me. Then what should I do now? So I have to skip this process until I connect or link them. So what is the number now? If you remember here, the address of program B is 0070. For 0070, we will observe that we have written modification records. And you observe that now object code is 0. Why it is 0? Because all the 3 values NDA, list A, list C are unknown to us. So let us look at the object program now. So for object program for program B, line number 70. So what is there? NDA. Line number 70. What is there? List A. Line number 70. What is there? List C. You please remember the values here. It was NDA minus list A plus list C. Same thing we have used. NDA minus list A plus list C. So depending upon what is there in the expression, the same symbol is used. If it is a plus, we will write plus. If it is a minus, we will write a minus. That's all. But whatever it is, at line number 70, 3 values are unknown to me in program B. Okay. Now I know what are those values. What are those values? NDA minus list A plus list C. So now let us come to the table now. What is NDA? NDA is 4054. What is list A? 4044. So 4054 minus 4040 is 14 plus list C. What is list C? 4112. So 14 plus 4112, 4126. That's what we have showed now. So 4126 is what we have seen from reference 4. Let us see program C also. When you are in program C, same thing at line at address number 42, we have a reference for NDA minus list A plus list C. So list C value is known to me here, but I don't know NDA minus list A. So what type of expression it is now? NDA minus list A plus list C in program C what type of expression it is. Is it absolute expression or a relative expression? What it is, absolute or relative? So in program C, list C value is known. So value is known, it is absolute. What is pending? NDA minus list A. I said, if you have a proper pair of data, it can be considered as a absolute. When there is no proper pair, when there is an odd number of values like this, then we have to take it as a relative. So how many unknown values are here now? 2 unknown values. 2 means it's a one pair. So one pair of data is going to be absolute only. So the same expression NDA minus list A plus list C was relative in the previous 2 programs, but it is a absolute in the current program. So this is how we have to identify. Fine. Now having said that, so reference for list C value is what? List C value is 30. We know the value of 30 here. That's why we see the object code is given 30. But what is missing here? NDA minus list A. If you look at the object code at 0042 for program C, you will see these two. What is that? List A and NDA. So NDA and list A. But we will see one more also. Why? Because where are the list A and NDA? They are part of the program A. So when they are part of the program A, they need to be added with the program C now. So let us see NDA minus list A. What is NDA? NDA is 4054 minus 40, that is 14 plus 30. Plus 30 means already it is there, no? List C. Okay, list C is already given here 4112. When you add 4112 plus 14, you will get again 4126. So 4126 is getting. So whatever may be the type of program you have, if you have maintained properly, if linking is successful, you will get the correct data. That's what we want to prove it here by taking the same instruction across the programs. So that is the concept of the linking of a program. So the entire concept of linking here is how we are going to use multiple independent programs such that there is some interdependency between or among them. So I need to club them when it is gone for the execution or before loading. If that is the case, what should I do? We need to link them. So while linking, what is going to happen? Any unresolved data like this, when I'm in program B, I will not be knowing what is the value of a program A. So that is unresolved for me. So I can resolve them. How? By linking them together. After linking is over, you will be getting a table like this. What is a table? That means each program's starting address and ending address is known to us, so that I can connect with the other programs easily. Once this is projected as a single entity or single program, then all the unresolved challenges or unresolved labels will be resolved and I can continue with the program. So once that is done, program will be easily loaded into the system and later executed without any trouble. So that is the concept of a program linking. So this is what the program linking, what we have to mean. So after linking is over, as we know, this is how it is going to be looked in the memory. Everything will be in the continuous memory location. There is no gap at all. But before that, they're all separately existing. Now after linking is over, they will be put together in a continuous memory location. That is the idea. So for this purpose, we need to take the same control sections which are independent of each other. Later, once that is done, we need to club them. So this diagram is important from exam point of view. So it's not a big deal. Just we have to write how the mechanism is happening. You need not by heart any of them. Numbers of is your choice. You can use any number here because address is address. But what you have to demonstrate is you have to demonstrate this plus mechanism, this plus addition operation, how it is being. That means this entity is different. This entity is different. Both of them are added together so that I can figure out this value. That's what we need to demonstrate. You take a number of your choice and after adding, show that this is matching with the what is expected. That's what the program linking is. So that's all for the day. So if you have any doubts, let me know. Otherwise, we can wind up. If you don't have any doubts, we can leave.